The roof sun's going to take up.
On the packet, questions before we collect it.
We played Valley
Is that a campaign?
Can you look over?
Sorry, Caitlin, I didn't hear you. I'll do those things, all right.
I dropped my potato water.
Number 9. Let's see if I can find it here to use this slide. We don't need the graph, it's just on here. Problem number 9 says, is it possible for a triangle to have angle measures in the extended ratio 1 to 4 to 7? What do we know about the 3 angles of a triangle?
They add up to 180.
They always add up to 180. We're going to do, I believe there's something in the notes today that's more like this, and we're going to do an example. Please make sure that when we get to that you write it down carefully in your notes. 1, 4 to 7, every time you see something like this, all you're going to do is put X with each number. Put an X with each number. So instead of, if I drew the triangle, instead of this angle just being 1, what would it be? If I put an X with each number.
1x.
1X. What would this angle be? 4X. This angle? Now, if you have that picture, what would you do with those 3 numbers? You guys just told me the rule. What is the rule? So what equation would I set up?
1x plus 7x plus 4x equals 180.
And if you did what Kellen did and went ahead and collected the like terms and put them all together first so you had less to write down, there's nothing wrong with that. What is 1x plus 7x plus 4x? 12x equals 180. How are we going to solve that?
Divide by 12.
Grab your calculators, divide both sides by 12. I am going to start checking calculators again, so make sure you start bringing one every time.
I got 2.
You got what?
I got 2. Who?
So get it out.
Which one?
AJ, laugh at him now because he's sitting in the hallway in about 10 seconds for the rest of the class. And then I'll get a hold of the basketball coach and see if we can take care of it.
I got his number, by the way. We're close.
We're close.
What is it?
15.
15?
15.
What they ask us to find?
The angle measures.
Find the angle measures. So is that our answer, 15?
No.
You gotta put it in for x.
You got to plug it in for each one. So one of the angles is what? 1 times 15 is what?
15.
So one of them is 15. Ignore that. That's supposed to be a comma. Plug it into the others. What's the other 2 angles?
7 is 105. 60.
So that's the 3 answers that go out there on the blank. And it says, find the 3 angle measures. If not, explain why it is not possible. Well, it is possible, so we don't have to explain why it is not possible.
Okay. Can we do 12?
So that's your answer. I'll get to it here in a second, all right?
19.
19. Look at 19. What's this tell us about this triangle?
It's not sausage.
Those 2 angles are congruent. What else does it tell us?
It's not sausage.
Isosceles. So what do we know about the sides across from those 2 angles? They're congruent. They're the same. So those 2 sides are congruent. Did they tell us anything about those 2 sides?
Yeah, they're
3x minus.
One of them is 3x minus 6. Ignore that.
No, there's 2x plus 6.
It didn't.
2x plus 6. So what do we know about those two?
They're congruent.
They're congruent. What's that in algebra?
Equal.
So we put an equal sign in between. So that's our equation.
Oh, you're so good.
How do we start to solve that?
Plus 3, 6.
Plus 6.
What did I just
Before
say?
that.
Minus 2x.
Minus
Oh.
2x. Remember, you want to get all the x's on one side first, otherwise it's going to mess you up. What is 3x minus 2x?
1x.
What else is still left on the left-hand
Minus
side?
6.
Equals what's on the right-hand side?
6.
Now what?
Add the
Add
6.
Add 6.
6 equals.
You end up with what?
Close.
X equals
What they ask us to find on these problems?
4. X.
Just find x. So do we have to go back and plug in?
No.
So x equals 12.
You would do 15.
Luke, which one did you say?
12.
What's those two tick marks tell us about this triangle?
Or
They're congruent.
The two sides are congruent, so what kind of triangle is it?
scaling? Oh wait, no. Isosceles.
Isosceles. If those two sides are congruent, what do you know about the angles across from those sides?
They are.
They gotta be congruent. So this angle has to be congruent to
That.
that angle. Now let's see what they say here. They tell us this angle is 130 degrees. This angle is x. Well, if this angle is x, what's this angle up here have to be?
X.
What do you know about the three angles of a triangle?
They're all equal.
So tell me what equation I can set up.
130 divided by
2x
130
plus
plus
2x
2x.
x plus x, which is 2x, right? And all that should equal how much?
180.
You gotta know how to set up these equations. Not that difficult. This angle plus this angle has to equal 180. How do we start to solve this?
130 or 180.
Subtract 130 on both sides. A lot of you, I think I've talked to Ethan O about this in the past. A lot of you confuse yourself because you don't do this step by step. You don't write it out like I'm writing it out. You think you can do it without it, and then that gets you lost when you're doing the algebra. If you do it out this way, it doesn't take that long. What happens over here on the left?
That cancels.
What are you left with?
2x.
Equals,
150.
50.
what is it?
Oh, 50.
Now what?
50 divided
5 by 2, x equals 25. And I know Ethan O, as soon as I said his name, he said, I don't have to write it out, I can do it all in my head. And that's great on some of these problems. On other ones that aren't so easy, then you can't do it out, and if you get used to doing the steps, then you don't have trouble on the harder ones. It's when you try to do the easy ones in your head and not do any of the work that you have trouble on the harder ones. What'd they ask us to find on this one?
X.
Just x, that's it?
Find the value of X.
So we don't have to plug back in or anything?
No.
Somebody tell me how much is this angle right here, even though they didn't ask us for it?
25.
25. How about this angle up here?
25.
What's 25 plus 130? It should be 180, right? And we could check our answer to make sure we didn't mess up. Next one, Branson, which one did you say?
15.
How many triangles in this picture before I finish drawing anymore?
3.
3. Tell me something about this small triangle down here.
all the
It's
sides
all
are equal.
90.
Alright, so not only are all the angles congruent, what's that called when all the angles are congruent?
Right angle.
Equilateral.
Like an equilateral.
The other one.
Equilateral.
Equiangular. And if that's true, then what do we know about all three sides?
They're
they're equal, so I'm gonna put a couple of marks on each one of those. All three of those little segments there are equal to each other. Oh, I'm sorry.
Are you good?
They already had one mark on them, didn't they?
Yeah.
Yeah.
So they already had, this had one mark, well then how many marks am I gonna put on the other ones? One, so just one mark on that one mark on that one, I should have paid more attention. And we also have one mark up here, and they tell us it's 20. What's that tell us about each of these sides then? They're all 20, so let's write in 20 there, 20 there, 20 there. I don't know if that'll help us or not, but it's something that we know.
What if the bottom one is 5 wide?
Oh, you think?
Yeah, why is?
So the bottom one's 5y, well then it is gonna help us in it, because what do we know about 5y? It has to equal what?
Yeah.
20, so
So y
5y
equals
equals 20.
Oh, wait, my fault.
Now what?
Divided by 5.
Divide by 5, what's y equal?
4.
I bet that's one of the answers they're asking us for.
Yeah. Y equals.
Now, not only do we know that all these angles are congruent, somebody tell me the measure of this angle down here at the bottom. 60 degrees, so let's write that in. That's 60. What's this angle over here? 60. What's this angle right here?
60.
I'm not sure what all they're asking us for. I'm just finding stuff that I know. If this angle's 60, what do you know about this angle and this angle together?
Or they equal 180.
They add up to 180. So if this angle's 60, what's this angle over here?
120.
120. So let's write that in there. I don't know if we need that or not, but pretty easy to find.
The other two angles are congruent.
The other two angles, if we look at this triangle, what Kellen's saying is, what kind of triangle is that triangle?
Right angle.
Isosceles.
Oh, wait, my fault.
Isosceles, because it's got two sides congruent, right? If those two sides are congruent, what do you know about the angles? Shh. What do you know about the angles across from those sides?
There you
They have to be congruent. So this angle has to be congruent to that angle.
It has to equal 180.
That looks like a
30.
thing.
So the three angles of the triangle have to add up to 180. So we already got 120 right here. What's 120 minus 180?
30.
60. Does that mean this angle's 60?
No.
This angle's 60?
No, you gotta divide it by 2.
You gotta divide that by 2. So 60 divided by 2 is what?
30.
So this angle's 30. This angle's 30. I think they said that this angle was actually x.
Yeah.
So what's x equal?
30.
30.
Is that a right angle?
Apparently not.
It really looks like a right angle.
I don't think it does.
On number
I don't see anything in that picture that looks like a right angle. Take your other piece of paper you got laying there, Branson. Take your other piece of paper you got laying there, Branson. Stick the corner of it in it. See if it matches up. No. Just one of the corners, not, get rid of the other piece of paper.
It does not.
Doesn't match up anywhere close, I don't think. Yeah.
Wait.
On number 14 is why.
Where's that?
Yeah, my paper's on it. It matches up.
That looks like a right angle.
It matches up.
It matches up.
Yeah, it does. It looks like a right angle.
Look at this. I think it matches up.
Oh, you're saying the whole big angle.
Yeah.
Yeah, that does sort of look like a right angle. I thought you meant this, I thought it was.
Oh.
Oh, wait. 60 plus 30 equals 90.
Oh, yeah, so
Oh,
it is.
It is a right angle.
Which one did you ask me about? 14?
Which one?
Minus 46. Is the bottom segment congruent to all the other segments since they're triangles?
It's gonna be 60, 60, 60. All the sides are the same, so yeah, y is 30. Other questions?
17.
17?
Can an isosceles triangle be an obtuse triangle? Explain.
Let's look at, if I erase some of this right here. Probably gonna erase more than I wanted to, but. What kind of triangle is this? It's an isosceles triangle. Oops.
And one of the angles are.
It's an isosceles triangle. Not only is it an isosceles triangle, but it's also what other kind of triangle?
Obtuse.
Obtuse triangle. How come it's an obtuse triangle?
Because the angle's above 90.
Angles are bigger than.
Because one of the angles is bigger than 90
And smaller than.
and smaller than 180. So can a triangle be an isosceles obtuse triangle?
Yes.
Yes. And what's your explanation gonna be? You could just, for your explanation, I would accept something like, you just draw that triangle. That angle's 120. These two sides are congruent. That would be an isosceles obtuse triangle.
Okay.
Can a triangle be a right obtuse triangle?
No.
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 Uh-uh.
Can a triangle be an acute obtuse triangle?
No.
No. Can a triangle be equilateral obtuse triangle?
No.
Like
No,
you say,
because in
it
an
can't be
equilateral triangle, what do we know about all three angles?
They're all equal.
They're all 60 degrees, and they're all
It
equal.
can be an acute triangle.
Can it be an acute obtuse triangle?
Yeah.
No.
It said that.
But it
I don't
can
know.
be an acute
Why?
isosceles.
So if it was a acute obtuse, what's it mean to be an acute triangle?
But it has an angle.
Not a angle.
The angle, I don't know.
And what's an acute triangle?
All angles less than 90.
All angles are less than 90. So can all the angles be less than 90, then one of them be more than 90? No, it doesn't work.
Can we do 22?
22.
This is a very odd shape.
Mine doesn't look anything like their picture, because they tell us this angle right here is supposed to be how much?
90.
90. So I'm just gonna write 90 degrees in there, all
I
right?
understand how it's 90 feet.
So that's supposed to be a right angle. They tell us that this angle is supposed to be congruent to this angle. And they tell us that this side is supposed to be congruent to that side. Is that correct?
Yeah.
And in the bottom left.
And I'm just gonna put this in here. This is 30 degrees.
3x.
Yeah, I'm not worried about the x right now. All right? So, first thing, looking at this triangle, again, my triangle looks absolutely nothing like it should, so don't go by that. Forget this triangle over here is even there. What do you know about the three angles of a triangle?
Out of 180.
They add up to 180. Well, we know two of them.
So the top one has to be 60.
90 plus 30, what is 90 plus 30? 120, subtract that from 180,
So
Yeah, 60.
so 60. So this angle's up here is 60. If that angle's 60 degrees, what's this angle over here?
60.
Because they told us they were congruent, right? So write 60 in there.
And then if those two sides are congruent, then the other.
If those two sides are congruent, then what do you know about the angles across from them?
There's
They have to be congruent, so that's 60 degrees.
So the top one's also 60.
Well, if that's 60, that's 60. What's this angle up here have to be? 60 degrees. So what kind of triangle is this one over here on this side?
Equal.
Equilateral or equiangular, either one. All the angles are congruent, then that also means that all three sides are congruent, not just two of them. Now let's look back and see what they asked us for.
X.
They said that this is 3x, well, you just told me that that angle right there was how much?
60.
So 3x should equal what?
60.
Divide by 3. What's x equal?
20.
What else did they ask us to find? Anything?
That's it.
Just find x. So x equals 20. Did we find a whole lot more stuff in there than we actually needed to?
Yeah.
Yeah, and that's what you should do. Go through and find all the stuff you know, then worry about what they asked you. Did it take us like an hour to do all that? No, it took us a couple minutes to do the whole thing. If you just look at the 3x and say, okay, how am I gonna figure out 3x? You're probably gonna spend about 15 minutes trying to figure out just the 3x instead of figuring out everything else. Yes, France?
Are we gonna do any more like stuff in our book
Yeah. Yes.
today?
Next question. Are we just ready to turn it in?
The one right after that, I don't know. 23.
23?
It's
It looks really easy. I didn't think. just yelp one.
What's this tell us about this triangle?
It's an isosceles.
Isosceles. If it's isosceles, what do you know about those two angles across from those sides? They're congruent. So one of them, they tell us is x, so what's the other one?
X.
And they also tell us that this angle up here is 3x. What do we know about the three angles of a triangle?
They need to add up to 180.
So tell me the equation I can set up.
3x plus 2.
Plus 2x equals 180.
Now, some of you are wanting to go ahead and combine like terms, that's fine. What is 3x and 2x?
5x.
So you could have done that first if you wanted, without writing down this other step here. Now what?
5 divide.
Divide by 5. What's that give us?
X equals
60?
36.
36.
60?
36.
Oh, no.
It's 36?
Yes.
Oh, so you might want to write down the right answer, because Branson's just hollering out numbers. I'm going to start writing down the problems that people just holler out stuff. He's got a calculator laying right there that he could have used instead of just hollering out something. Use your brain a little bit, Branson.
EEA can go to angle EAB. And then to
Other questions? Are we done?
come on, guys. Name something here. I don't want to do class.
We do 11.
11. It's probably the last one.
You got most of it.
Problem 11, in triangle ABC and triangle RST, angle A is congruent to angle R, angle B is congruent to angle S. What can you say about angle C and angle T? So first thing I probably ought to do is draw a picture of triangle ABC. I'll make that A, that B, that C. Is that all right? Did they tell us what triangle ABC looks like?
No.
Do we really care?
No.
No. But they did tell us that some of the parts in the other triangle were congruent to those. So I'll try to make this one sort of look like it. It doesn't have to look exactly the same or anything. Angle A is congruent to which angle in the other triangle?
More.
So if angle A is this one, I'm probably going to put angle R right here just so I don't confuse myself. What do I know about those two angles?
They're congruent.
So let's mark them as congruent.
B and S are congruent.
B and S are congruent, so B's right here. Where's S going to go on this triangle then?
Same spot.
Same spot down bottom left. What do we know about angle B and angle S?
They're congruent.
So can I mark them like this?
No, because then that means that A and
Means all of them are congruent, so you need to put 2 marks in there. What can you say about angle C, and the only place angle T can go is right there? What can you tell me about those two angles?
they're congruent.
They have to be congruent. And we're going to have a rule, and that rule is going to say if 2 angles in one triangle are the same as the corresponding angles, or 2 angles in another triangle, guess what has to be true about the third pair of angles?
They have to be congruent.
They have to be congruent. Let's make up a number, because I don't hear a whole lot of stuff out there.
80.
What's angle A?
80.
80? That means angle R is 80. What's angle B?
20.
20? That means angle S has to be 20.
T and C are also 80.
What's 80 plus 20?
100.
100, subtract that from 180, what's that leave you with for angle C here? 80? What's 80 plus 20? 100, what's that leave you over for angle T here? 80. What do you notice about those two? They're the same. Did it matter which numbers we picked when we were picking the measures of these first 2 angles? No, whatever we pick, these 2 added together is going to add up to equal the same as these 2, and this third pair is always going to be those 2 subtracted from 180. So it's always mathematically, it has to be the same. Can't be anything different. So what do we know? What's the answer here? What do we know about angle C and angle T? They're always congruent. Angle C has to be congruent to angle T. That's the answer they wanted. Make sure your names are on those. You're going to lay them right here when you get back to your desk. Get out the notes. You're going to start copying down the notes from the board. Please make sure your names are on them.
Mr. Ebersole?
Yes.
I don't think I did this in. I need to get it like done. Can I do that?
Yeah.
I was working on the other one, so I grabbed it.
Maybe if I put my name on it. Did you have any no-name packets from last?
Does it still have a dash on it? Is that what you're saying?
I had zero.
Sure it has a zero. Sure it doesn't have a dash.
I don't think that's a dash.
Because I haven't put those in the computer yet, so no one has a read. The last packet,
Oh, yeah.
that's what, the last packet I haven't put in.
Huh.
You're talking about
It might have been the very first one.
the chapter 4 packet, right? The one with all the graphs on it?
I don't know.
The crossword puzzle, that's the one, I have it in.
Yeah.
Computer.
Did you give the no-name packet? I wonder where it went. Yeah, I turned that in for like points.
Yeah. No, that one I didn't have any other names for.
There's no reason to do that too.
In fact, I think we passed them back last time, didn't we?
We haven't passed these things for a while.
Remind me, it must have been my other class. Oh, yeah. All the Brown classes, I passed all them back. I didn't pass your guys' back yet. It's up there. Please make sure you're keeping your binders in order. Not gonna do a whole lot with this slide. We've written this down like 4 times now. What's a scalene triangle?
No sides are congruent.
No sides congruent. What's an isosceles triangle?
Two sides congruent.
At least 2 sides. Now, a lot of books will say an equilateral triangle is also an isosceles. That's why this says at least 2 sides. I don't know why they do that, just to try to confuse you, I guess. So all equilateral triangles are isosceles triangles, but not all isosceles triangles are equilateral triangles. Remember, with an isosceles triangle, it looks something like this, maybe. I'll tell you what, let's do this. An isosceles triangle looks something like this, where 2 of the sides are congruent. Turned it sideways because as soon as I don't turn it sideways, then Michael thinks that the base always has to be on the bottom, and is that the case? Does the base always have to be on the bottom?
No.
No, it doesn't matter. So this right here is an isosceles triangle, right? So
Yeah.
that's an isosceles triangle. When I turn it this way, does that mean it's not an isosceles triangle anymore?
It's still an isosceles.
Still an isosceles triangle. It's just, this is the base, and these are the 2, what were these 2 sides called? The congruent sides, which are the legs. Equilateral triangle. If a triangle's equilateral, what do you know about all 3 sides? They're all congruent. An acute triangle. What do you know about an acute triangle?
3 sides.
3
Sides must be 3 angles.
3 acute angles. How about an obtuse triangle?
1 angle must be obtuse.
1 obtuse angle. How about a right triangle?
1 right. Exactly 1 right angle.
Exactly 1. Equiangular, all 3 angles are congruent. And what's the measure of all 3 of those angles?
Always 60 degrees.
Always 60 degrees. Draw this on your paper there again. If a triangle's equilateral, then what else do you know about it? It's also equiangular. So it's always both. If a triangle's one, then it's the other. Equilateral, it's equiangular. If it's equiangular, it's equilateral.
Okay.
Always. So if I give you this triangle, 60, 60, and I tell you this side's 10 centimeters. What can you tell me about that side over there?
It's 10 centimeters.
It's got to be 10 centimeters. exterior angles. We had a rule about exterior angles.
Yeah.
Fill in what you need to fill in on this part, probably on the back of the page. Is that right? Which angles are interior angles in this picture?
4, 5, and 6.
Because why are they called interior angles?
Because it's
Inside the triangle. And which ones are exterior angles?
1, 2,
1, 2, and 3. You make an exterior angle of any shape. It doesn't have to be a triangle. It could be a rectangle, pentagon, hexagon, whatever. So if I have this pentagon, I make an exterior angle just by picking one of the sides and extending it straight out. That's an exterior angle. So it's got to go straight out. Whatever shape it is that you pick. You extend one of the sides straight out, that's an exterior angle. You always want to just have one exterior angle per corner, per vertex. So in other words, watch closely on this. I extended this side straight out to make angle 1 there. I don't want to extend this side straight out to make another exterior angle. This is an exterior angle, but what do you know about this angle and angle 1? They're vertical angles, so they have to be congruent to each other. Do we really want all that? It just confuses the picture more. So usually we only want one exterior angle at each corner for each vertex. What do you know about the 3 angles of a triangle again?
They all add up to an
They add up to 180. What do you know about angle 1 and angle 4 in this picture?
They add up to 180.
They add up to 180. How about angle 3 and angle 6?
180.
They add up to 180. How about angle 2 and angle 5? They add up to 180. So on, so on, so on. So we know all that information from that picture just by our rules. Fill in what you need to fill in on this slide. Again, a corollary. Corollary is same as a postulate. So if you wanted to mark that out and put postulate, mark this out and put postulate, fine. Anybody remember, you got postulates, corollaries, what's the other one that goes along with those two? Axioms. They're all the same thing. What's the one that's different from all 3 of those? A theorem. Theorem is a mathematical rule that must be proven true. Postulate, corollary, or axiom is something that we just take for granted is true.
I feel like this class teaches more vocabulary than English.
You'll have to complain to your English teacher.
Or
about
don't, or not. Please.
Sure, that's Mr. Longfellow.
With this one, I don't care how you do it. With this one here, I'm going to draw it up above here, but it goes with theorem 5.2. Draw a picture, it looks like this. Triangle. What's this angle out here called again?
Exterior.
An exterior angle. So draw a picture, it looks something like that. I don't care how you do it, find some place on there on your paper, take an arrow and point towards theorem 5.2, whatever it takes, that's up to you. Just make sure you can understand it. You're the only one that's going to be reading your notes. Give me a number I can call this angle right here. 4. So put 4 in there, give me another number.
3,
Give me another number.
2,
Give me another number.
1.
Which angle is an exterior angle? Angle 1. The other 3 angles, 2, 3, and 4, are called what kind of angles?
Interior and
interior angles. This theorem says the measure of an exterior angle. So the measure of angle 1 equals the sum of the two non-adjacent interior angles. Alright? And I think when we covered this last time, Caitlin's holding her head because she's going, oh my God, Ebersole, we already went over this. Because every time I tried to go over a problem, she wanted to use this rule. I remember in class, see, I do remember some things. She wanted to use this. I was trying to use other rules, and she said, no, those two got to add up to equal that angle. Do this. What two interior angles have to add up to equal angle 1 here?
3 and 4.
So circle angle 3, circle angle 4. And write add. You add those two together, the two non-adjacent, the two that are not hooked to the exterior angle. Those two have to add up to equal angle 1. That's all this says. This book calls them non-adjacent interior angles. Old books call them remote interior angles. Anybody have any idea why they call them remote interior angles?
That's the either, so.
That's what remote means. Remote means what? By itself, alone, somewhere. Alright? So they're the remote, the ones that are away from the exterior angle. Now, unlike what Riley back there has got going through his head, because I know what he's got, as soon as I say the word remote, I know what's going through his head. What is it, Riley? The TV remote. Why is it called a remote? The TV remote.
To the TV.
Because it's not connected to the TV. You can do what to the TV using that? Change the channel without doing what? Moving, without getting up and going up to it. Sorry, but when I was growing up, guess what we had on the front of the TV? Little dials. You had to turn it to change the channel. Alright? So it's called a remote control because it controls the TV from far away. Alright? Next one. If I have a right triangle, draw this picture for this one. If I have a right triangle, just draw some right triangle, put the little box in the corner. We'll call this angle 1 and angle 2. So write angle 1 and angle 2 and the other two angles. Tell me something you know about angle 1 and angle 2 in that right triangle.
They are cute.
They have to be acute. Alright? They have to be acute. They can't be more than 90 degrees. Alright? They can't even be 90 degrees. So they got to be less than 90 degrees. They have to be acute. Not only do we know that, but we also know what's true about the three angles of a triangle.
Yeah, that's 180.
Add up to 180. Well, if one of the angles is 90, how much is left over for the other two? 90. So angle 1 plus angle 2 always has to equal what? 90 degrees. And that means they're complementary. So write this down. Measure, remember that's what that little M means. Measure angle 1 plus measure angle 2 has to equal 90 degrees, or they have to be complementary to each other. Measure of angle 1 plus measure of angle 2 always equals 90. And what that allows you to do, just makes some things a little simpler on you. If I gave you this, I told you that was 90, this was X, and this angle down here was 40 degrees. Instead of saying the three angles of a triangle must add up to 180, what do we know about these two angles?
It must be.
They got to add up to
90.
90 degrees. So if this one's 40, all we got to do is say 90 minus 40 and you get what?
50.
So X has to be 50. Just makes it a little simpler. You don't have to do quite so much work. The last thing down here, we've been talking about this. How many right angles can a triangle have in it?
1.
How many obtuse angles? 1. Fill in what you need to fill in on this slide. I think it's on there somewhere, isn't it?
No.
No?
Yeah, oh, we did that on,
Yeah, we did it before.
Yeah, we did that on the screen too.
Don't know what we're on here.
Nope.
you write it down again. All of you remember it, right? Yeah. So let's do this. You gotta know the parts of an isosceles triangle. Alright? The two congruent sides are called the what? Legs. So that's a leg, that's a leg. The third side is called the
Base.
The base always have to be on the bottom.
No.
The two angles that surround the base are called the what?
Base angles.
Base angles. Don't make that harder than it is. What do you always know about the base angles?
They're congruent.
They always have to be congruent to each other. The third angle, this is the one nobody ever remembers. What's that third angle called?
Vertex
The
angle.
vertex angle. That's, bad thing is that's one nobody ever remembers, and that's the one that gets used the most. If they tell you you have an isosceles triangle, they're probably going to tell you that that certain angle is the vertex. All right? So if I did this, that's an N. Angle N is the vertex of this isosceles triangle. Tell me everything you can tell me about this triangle.
H and T have to be congruent.
Angle H has to be congruent to angle T, so we could mark that. Tell me something else.
The two legs have to be congruent.
Which ones are the legs?
NT and HN.
NT and HN. Just because it's standing this way, is that why it's that
No.
the case? No, it's the ones across from
The base.
the base angles, right? So this has to be congruent to that. What if I told you angle N was 30 degrees? Could we find some stuff here?
Yeah.
Yeah.
If angle N is 30 degrees, we just got done doing a problem like this on the homework.
N plus T equals 90.
Now be careful.
H would be 75,
Why is angle H 75?
because otherwise 75 is 150, and 150 plus 30 is 180.
What do we know about the three angles of a triangle?
We want to add up.
They have to add up to 180. So if this one's 30, how much is left over for these two? 150. Does that mean each one of those is 150?
No.
No, divide that by 2. So what's this angle? 75. What's this angle? 75. What if I told you this side down here was 10 centimeters? Does that mean this side's 10 centimeters?
No.
This side?
No.
No.
No, it doesn't tell us anything about those other two, so don't think that it does. This isn't on there anywhere either, is it?
We wrote that one down.
Yeah, we wrote it down. Do me a favor. On I don't care, just find the empty space. Find an empty space somewhere on your notes and draw this picture. Draw an isosceles triangle. Mark the two legs as congruent. And then what do you know about these two angles down here then? They're congruent. So mark them as congruent. Then draw in these arrows. Oops. Tag on it. Alright. My pen messing up. Draw in these arrows that look like this. The sides are congruent. Angles across from them have to be congruent. If the angles are congruent, the sides across from them have to be congruent. You guys seem like you knew that pretty well when we were doing the other assignment, so hopefully that won't be a big deal, but just to make sure you remember. An equilateral triangle, again, this, I don't think this is on your paper. I think I added these two just to go back over them. But triangle's equilateral. What do you know about all three sides? They're all equal. They're all congruent. What do you know about all three angles if it's equilateral?
60 degrees.
They're all 60 degrees. They're all congruent. They're all 60 degrees. Anybody know of a shape out in the real world that's an equilateral triangle?
like the hazard on the back
Yeah,
of a
Hazard sign is,
Back on Amish.
The,
any signs along the road that are
A
some
yield
kind of hazard
sign.
road.
That triangle.
That triangle right there, Ethan's
Can I go to
saying.
the bathroom?
God,
So,
That triangle.
something,
such a minute.
something I'll say. Used to be a poster in here, I might have gotten rid of it.
is there on the door?
No. It's close to the one I want, but. There was a poster in here that talked about shapes. It showed all the shapes like this right here. I still don't like this one. You can see on this one that I wrote on it because it calls this oval. There's no such shape as an oval. It's an ellipse, right? It's an ellipse. Now, there was another one in here. I can't find it now. And it gave, it's around here somewhere. But it gave all of the shapes.
Polygons are there?
It was polygons. Oh, that's right. I lost it. It got taken somewhere. No, it's not. It's not the small one.
Oh.
Because the small one's correct. We had a big one and it was incorrect because it had all these polygons on it. Looked just like this. Anybody remember the word that goes with all those? If all the sides and all the angles are the same,
Polygon.
starts with an R.
Regular polygon.
It's a regular polygon. It had all of those except for a four-sided. It had this. Is a rectangle a regular polygon?
No.
No. So every other polygon that showed is a regular polygon, and then it stuck a rectangle on
Alright,
there.
rectangle.
So what-
That's probably what happened to it. I probably threw it
Okay.
away because I was sick of looking at it and I knew a math person didn't make it up. This is on your notes.
When AJ gets back, can I go to the bathroom?
On this one, the exterior angles. Need to move this stuff around. Exterior angles. Angle 1's an exterior angle. What two interior angles have to add up to equal angle 1? 5 and 6. Does everybody see that? These two right here have to add up to equal that exterior angle.
Yeah.
Now we're going to do the same thing on the other. Angle 2. Which two interior angles add up to equal angle 2?
4 and 6.
So right in 4 and 6. This angle
4 and 5.
plus this angle has to equal angle 2.
4 and 5.
Angle, so 4 and 5, is that what we're saying on this next one? So right in 4 and 5. 4 and 5 have to add up to equal angle 3. Measure of angle 6 plus the measure of angle 3. What do we know about the measure of angle 6 and the measure of angle 3?
It equals
added together?
180?
Equals 180, so write 180 in there. All this we can get just from this picture. How about measure of angle 1 plus measure of angle 4? 180. About the measure of angle 2 plus the measure of angle 5?
180 again.
Let's run through these real quick. Get your calculators out, help me out. How can we find the angle A there? What do we know about three angles of a triangle?
They add up to 180.
They add up to 180, right?
Yeah.
So add those two and subtract from 180. What's it come out to be? 44? 34? Everybody agree with that? Yes, no, maybe? Is that right? You sure?
Yes, that's.
That's 34. What do we know about this triangle then? It's isosceles. So what has to be true about that side and that side? They have to be equal to each other. That doesn't help us on the problem, but it's something that we know. How could we find angle A in the next picture?
90 plus 67 minus.
Subtract it from 180. Now Michael's doing it the long way, because what's a shorter way? If you know that one angle is a right angle.
67 plus whatever equals 90.
Right. The other two angles other than the 90 have to add up to equal how much? 90 degrees. Yes. Sure. So what is the other angle? What's angle A? 20 what? 23, everybody agree with that?
Yes.
Write 23 in there.
You're good.
Next one, how can we find this? If we just, let's just say, this time let's just find x.
4x plus 2.
5x.
No, 4x. Where are you getting 5x from?
Oh.
2x plus 9
3x plus
equals
x
3x.
plus 2 is 4x.
I think he's on the wrong problem.
Are you doing the one on the right or the one on the left? 5x.
It's usually the way you go left to right, isn't it?
So where do you get
I
4x
usually go
from?
right to left.
Huh?
That was-
So is it?
Okay, the one on the left.
Is it?
So what do we do?
5x equals 90.
5x equals 90. How come 5x equals 90? Does this angle plus this angle always equal this angle?
No.
No, but we know that these two angles have to add up to be how much?
90.
90 if this is a right angle, all right? Does that work for all triangles?
No.
Only if it's a right triangle. So 5x equals 90. Now what?
X equals 18.
X equals what?
18.
18. Anybody else get that?
18.
Next one, same idea. This is a right angle. This is a right triangle. What do you know about these two angles?
3x.
They have the equals 90.
They have to add up to equal 90. So 3x plus what?
2
Plus
equals
Plus
plus
X.
90.
equals
90.
90. What do you do to start to solve that?
You
Fine, like
combine by 10.
What's that give you?
4x plus
4x plus 2 equals 90. Then what?
minus 2 to 90.
What's that leave us with?
4x equals 88.
X equals 22.
Does everybody agree with that?
Yeah.
X equals 22. What if they'd ask us to find the angles instead of just finding x?
Put it back in.
Plug it back in. How much is this angle? 22. And then we could find the other one. Several different ways you could find it.
68. Just said that.
If the measure of angle JLK, is this on there somewhere?
Yeah.
Now you're in the bathroom.
I say you say no.
If the measure of angle JLK is 78 degrees, where is angle JLK at?
Sorry, I didn't hear you over Branson. What'd you say?
Where is angle JLK located at?
At L. The
Right here?
vertex of L.
Does everybody agree with that?
Yeah.
So what do I put in there?
78.
So write 78 degrees in there. Remember, JLK, JLK. Make sure you're writing it in the right spot. A lot of people get confused there.
LJK.
LJK is 65 degrees. Where's that at? At the J,
the other
up
side.
here at the top. So what are you gonna write in there? 65. And again, I know it just kills some of you that you gotta write in some extra stuff here and there. It doesn't take that long and it's not that difficult. Write it in and it makes your life a whole lot easier as you go through and do the stuff. So if I got those two angles,
You add those up.
add them up, and what's that give us?
The measure
Right.
JKM.
That gives us the measure of that exterior angle, doesn't it? So this angle plus this angle has to equal that exterior angle.
Is it 37?
What is it? 143, so that's angle JKM. Does everybody agree with that? 143, is that right?
Yeah.
Yes, no, maybe?
Yeah.
143. Now, we also want to find this angle in here.
And then did 143 minus.
Just subtract that from 180, because those two should be supplementary, right? So how much is it? 37, I heard. Is that correct?
Yeah.
So if this angle's 37, just to check, to make sure that we're right, What should be true about these three angles that I have circled?
They all equal.
They should add up to 180. Check them out and see if they add up to 180. I don't think they do.
They do.
They do?
Yeah.
Sure?
Yes.
They did.
100%.
Yeah, those two add up to 280.
Yep. Next one, if the measure of angle JLK equals 70, and the measure of angle JK or LJK is x, and the measure of angle JKM is 2x minus 5. We're using the same picture. I'm just going to redraw it down here. So redraw the picture. J goes there, L goes there, K is there, and M is out here. Where's angle JLK at?
It's
Jake.
the L, point L.
Right here, so write 70 in there. We know that's 70, write it in. Angle LJK, where was it located at?
At the
J.
top, Jake.
So put what in its place up here? X. Angle JKM. Where's angle JKM? Explain
The
that to me.
outside.
It's the exterior angle out here, right? So it's 2x minus 5. So write that in there. And we want to find all the angles in this picture. What do you know about these two angles again?
They have to.
They add up to equal the exterior angle, right?
Yeah.
So those two angles add up to equal the exterior angle. So what equation are we going to set up?
70
70
plus X.
Equals X.
plus 70 equal x?
No.
Plus X.
70 plus x. This angle plus this angle
Equals 2x minus 5.
equals 2x minus 5. How are we going to solve this?
Give rid of the x.
So how do we do that?
Subtract it.
Subtract x on both sides. These cancel out. What's left on the left?
70 equals x minus 5.
X minus 5. On that side, then what?
So you add 5.
Add 5 to both sides.
X equals 75.
I know Michael does so well in this class. He doesn't want me to say his grade out loud, so he better be paying attention.
70, top angle 75, and those three have to add up to 180.
So what's this angle right here?
75.
75. So that's one of our answers. 75 degrees. Could we find this angle out here?
Yeah.
How?
Plug X in for 75.
So 2 times 75 minus 5. Do that on your calculator. 145, everybody agree with that? So that's another angle, that's this angle right here.
Is the
145, how can we find, because we still don't know this angle.
it's 35.
35, how'd you get that?
You added 75 plus 70.
Alright, these two angles right here together should add up to
180.
180. And we found all the missing angles.
Yeah. Good job.
Next one, find all the numbered angles. Give me an angle that we can find right off the bat here.
The right
The
angle.
2.
Angle 2, how can you find angle 2?
32 plus 90.
So 32 plus 90, do that. 122. So does that mean angle 2 is 122?
No.
You subtract that from
180.
180, and what's it give you? So write that in right there, 58 degrees. Find me another angle in this picture.
1.
Angle 1, how can you find angle 1?
90.
You could do the 90 plus 58. This is going back to what I said Caitlin was doing last time. These two angles should add up to equal this exterior angle, right? What's another way you could do it? What's true about these two angles? They should add up to 180. I don't care which one you do. This plus this should equal that exterior angle, or 180 minus 32 should equal that exterior angle. So what's angle 1? 148, write that in there. Give me another angle we can find. Angle 5, what's angle 5? 58, how come? What kind of angles are those? Vertical, what do we know about vertical angles? They have to be congruent. Find me another angle.
3 and 4.
What's 3?
122.
122, everybody agree with that?
Yeah.
And then 4 is 122.
122 also?
Yeah,
Those
and
are
then
vertical
6.
angles?
6 is pretty easy on
6 is,
6 is easy, what's angle 6?
90.
90?
And then that means 90 plus 58 equals
What?
1. How about the 7 now?
7?
732.
Go ahead, which one, 7 or 8, which one we find?
7.
7?
Yeah.
32.
Caitlin's probably right, it's probably easier to find, well, this time it's not really.
What are we trying to find?
Angle 5 and angle 7 have to equal 90.
Alright, so these two together have to add up to equal 90, because 3 angles of a triangle add up to
Angle
180.
6 is not a right angle.
So 7 is 32.
So this is 32?
Yeah.
Piece of paper up
90
It's
is
a 90.
8 is 148.
148, everybody agree with that? Did we find every angle in the picture?
Yeah.
to. Angle 6 is not a right
Yes.
angle.
If you go up there on the board, mine's the right angle, it's just when I moved it over to a piece of paper and printed it off,
It stretches out a
it
little bit.
stretches or does something.
I'm pretty easy.
Next one, is this one on your paper?
Yeah.
So you want us to find things.
And a triangle.
When we had this, and somebody mentioned this a minute ago, what's these two arrows tell us? Parallel. If that's the case, if these two are parallel, what's this line called?
The,
Starts with a T.
translate the.
Transversal. So what kind of angles are that 43-degree angle and X down there?
43 and X are alternate.
Alternate interior. So what's X have to be?
43.
43. So that's one of our answers. What can you tell me about, if this angle's 75, what can you tell me about this angle over here?
75.
They didn't say that we need to find it, but we're gonna put it in there.
And that
If
means
this angle's 75, what's this angle?
105.
105.
That means the other one's 105 also.
This one up here is 105.
Yeah.
And then that means Y is.
How can we find Y then?
105 minus 43.
105 minus 43?
I think.
105
Plus.
Oh, my fault.
105 plus 43, what's that give you?
148.
148. Now what do you know about 3 angles of a triangle?
Yeah, that's 180.
Add up to 180. So 180 minus 148, what's that give you?
32.
32 degrees.
And then the bottom left one's also 32.
This would also be 32. These are the two that they wanted, just X and Y.
Easy.
Easy stuff, Branson.
Yeah.
I'll remember that. We'll take a long quiz next time. Yeah, because Branson and Kellen
What?
get on my nerves.
What did I do?
Kellen thinks that since I yelled at Michael a little while ago because he was talking, that I didn't know that Michael and him were both talking. I just said something to Michael. Now, does
That
that
was a
answer your
basketball
question, what you did?
I think it does.
Next one.
That one's a basketball store, so it's okay.
What?
Next one. Not my class.
You're
Here.
weird.
On this. This is one of those 2-angle problems. We did some of them at the start of the year, so write 2-angle problem there somewhere. Above it, something. If you remember those 2-angle problems, we did this at the start of the year. We just said, we wrote down angle 1, angle 2. Write that on your paper. In a right triangle. So if it helps you, what kind of triangle are we going to draw?
Right.
A right triangle. In a right triangle, the measure of one acute angle is 5 times the measure of the other acute angle. Find both acute angles. So we said when we were doing the 2-angle problems, we're going to let angle 1 just normally, about 99.9% of the time, it's going to be just what? X. Some variable. And we probably said that Josie didn't have to use X. If she wanted to use J, whatever letter, it doesn't matter, right? So now we read the problem and we're going to figure out what angle 2 is. It says angle 2 is 5 times the measure of the other angle. So what are we going to put in here in place of angle 2? 5x. We're looking for these two angles. So we know that this angle is x, this angle is 5x. What can you tell me about those two angles? They add up to 90. So what equation can I now set up?
6x equals 90.
6x equals 90. Does everybody see where he got 6x from? 1x plus 5x, right? So he just already did 1x plus 5x. He has skipped a step. So 1x plus 5x equals 90.
Actually equals 15.
But then 6x equals that. What's x equal?
15.
Is that our answer?
No.
No.
You gotta put it.
We got to plug it in, right? So what's one of the angles?
15.
15.
15 degrees.
And then you do 5 times
We
17.
do 5 times what?
15.
5 times 15. Plug it in for this angle.
And you get 17. 75.
Those are our two answers.
My English is not very good.
On this one, I said this earlier, write this down on your paper there. Always, I should say always, my thing's messing up. Put X with each. So everybody know that that's a number symbol? Always put an X with each number. Anytime you see a ratio that looks like this, put an X with each one. So instead of 3, this is going to actually be what? 3x, 6x, and 9x. What do we know about the three angles of a triangle?
Yeah, it's 180.
So what equation am I going to set up?
3x plus 6x plus 9x equals 180.
3x plus 6x plus 9x equals 180. Could I draw the triangle if I wanted? That way I have a picture to look at. Yeah, if you need to draw it, draw it. If you draw the triangle, one of the angles is 3x, one of the angles is 6x, and the other one's 9x. And then 3 angles of a triangle add up to 180. How do I solve this?
Do you combine like terms?
What's that get you? 18x equals,
180.
now what?
180 divided by 18.
Divide both sides by 18. X equals 10. Is that our answer?
No.
No, what they ask us. Find the 3 angles. How am I going to do that?
3 times 10.
Plug in right here. 3 times 10 is how much?
30.
So 30 degrees. 60 degrees.
30, 60, 90.
90 degrees. Those are our 3 answers.
30, 60, 90.
That's your assignment, page 293.